Not only can we take powers of numbers, we also can take powers of this imaginary number that we now know called I. We know by definition that the square root of -1 is what gives us I. Keep in mind, that does not mean that I is equal to -1. I does not equal -1, I equals the square root of -1. It's a very common misconception, but you have to keep in mind that definition. Now, when we look at powers of I, let's start off with I squared. We know that I is the square root of -1, and we want to square that. Well, based on previous work with radicals and with exponents, we should note that when we take something that we're looking for the square root of, and we square it, the square of a square root, those two operations are inverses, and they simply undo each other. So we are left with the radicand itself, which is -1. So we know that I squared is equal to -1. This is something that you need to memorize. You must know this. You will have to work with this frequently throughout the remainder of this course. You must memorize that I squared is equal to -1. All other powers of I can be figured out if you know this one. Now, knowing I squared is equal to -1, let's figure out what I to the third would be. Writing this as something times I squared. Well, we know that I squared times I would be I to the third. We just determined that I squared is equal to -1, so this is the same thing as -1 times I. Well, -1 times I would equal -I. I to the fourth, we can figure out very similarly. I to the fourth would be equal to I squared times I squared. Well, we know that I squared is -1. The second I squared is also -1. And -1 times -1 is +1. So I to the fourth is equal to +1. We could continue in this manner to determine powers of I. I to the fifth would be I squared times I squared times I. Each of those I squareds is equivalent to -1 times I. -1 times -1 times +I would equal +I. I to the sixth could again be calculated very similarly. I squared times I squared, well, that's I to the fourth, times another I squared would be I to the sixth. Well, each of those I squareds is equivalent to -1. So -1 times -1 times -1. Multiply 3 -1s and you get a -1. You should be noticing something here. I to the first, it's just I squared is -1. I to the third is I to the fourth is +1. I to the fifth is I, the same thing as I to the first. I to the sixth is -1, the same thing as I squared. I to the seventh, then, if this pattern continues to hold, should be the same thing as I to the third. It should be equivalent to -I. Let's see if that continues to hold. I to the seventh would be I squared times I squared times I squared times I. Each of those I squareds is equivalent to -1. So -1 times -1 times -1 times I. Well, that, if we multiply, becomes -I, which is the same thing as I to the third. We have this pattern that is repeated. The pattern is I to the first is I squared is -1, I to the third is -I, and I to the fourth is +1. Anything after that simply repeats. So I to the fifth would go back to the same thing as I to the first. I to the sixth would be the same thing as I squared. I to the seventh would be the same thing as I to the third. I to the eighth would be the same thing as I to the fourth. So we have this pattern of 4 different answers that we can get. Any power of I has to be one of these 4 things. So if we were interested in figuring out the value of, say, I to the 20th power, the first thing we have to do is figure out how many times we would go through this set of 4, because we only have 4 different options. So take your exponent, that 20, divide it by 4, and look at the remainder. In this case, the remainder is 0. So since our remainder is 0, that means that we are going to be at this last power of I, so it would have to be equivalent to I to the 4th. So I to the 20th would equal 1. If we were interested in I to the 30th power, we'd do the same thing. 30 divided by 4, because there are 4 different options. Well, 30 divided by 4 is going to be 7, but there are 2 left over. So that means we have 2 pieces through this next rotation. So I to the 30th would have to be equivalent to I squared, which is equal to -1. If we were to be looking for the value of I to the 15th power, take 15, divide it by 4 to figure out how many times you go through this pattern. So 15 divided by 4 would be 3, with 3 left over. So that means we have gone through 3 full rotations of our pattern of 4, and 1, 2, 3 pieces through our next rotation. So I to the 15th would have to be equivalent to I to the 3rd, which is equal to -I. Any power of I can be figured out in this way. So if you have memorized that I squared is equal to -1 and can use that to establish the pattern of I squared, I to the 3rd, and I to the 4th, you can then determine the value of any power of I simply by going through this pattern.